Welcome to the genetic mapping of emperor penguins. Today we will be looking at the genetic cross of two heterozygous emperor penguins. The emperor penguins can vary in height, chest color, and fishing behavior. Penguin 1, named Snowy, is tall, orange-chested, and likes to fish in groups. Penguin 2, named Pongo, is short, yellow-chested, and likes to fish alone. Tall is dominant to short, yellow-chested is dominant to orange, and group fishing is dominant over solitary. Here are the chromosomes for the parents Snowy and Pongo. Snowy's genotype is big H, little y, big F, and Pongo has little h, big Y, little f. Below, we see the chromosome for the possible progeny of these penguins. Now we need to look at the given genetic map in order to determine the probability of the possible gametes for the baby penguin. In this three-length map, the distance between the first loci and the chest color loci is 10 centimorgans. The distance between the chest color loci and the fishing behavior loci is 21 centimorgans. There is also a coefficient of coincidence value of 0.52 and an interference value of 0.48. The distance between each loci determines the likelihood of crossing over, where a longer length has a higher chance of crossover. There are four possibilities: DCO, double crossover, SCO1 and SCO2, which are single crossover in region 1 and region 2, and NCO, where it's no crossover. Now let's look at our model to determine the gametes for each. Here's our genetic map. On top we have Snowy and on bottom we have Pongo. With no crossover, we would see no change. Now if we saw single crossover in region 1, it would go from big H to big Y to little f. So we have to flip these, and we would get little h, little y, big F, big H, big Y, little f. Starting back at our original, if we were looking at single crossover in region 2, we would start here, H, little y, and then cross to little f, meaning we would have to flip these two. And we would get the gametes big H, little y, little f, little h, big Y, big F. And in the last double crossover, we would cross and then cross back, meaning the middle would flip. And we would get big H, big Y, big F, little h, little y, little f. And here you can see written out all of the possible genotypes. Now let's calculate DCO and SCO1. So to find the probability of a double crossover event, we multiply R1, R2, and C. We get the probability of 0.01092. And if we wanted to find the probability one of those gametes, we would divide that by 2 and get 0.00546. With a single crossover event, we take R1 minus the DCO, which would give us a probability of 0.08908. Finally, here are all the possible probabilities.